Chapter 4, Separation of Substances. You will learn type of mixtures, pure substances, mixtures, heterogeneous solution, homogeneous solution. Quick review. We have learnt earlier that matter is that which has mass and occupies volume. When we look around us, we see various kinds of matter, starting from our food, clothes that we wear, the houses where we live, and the many things that we use in our daily life. All these are made up of different materials. You have also learnt that these materials can be solids, liquids, and gases, depending upon their physical state. Pure substances and mixtures. Usually the water that we drink and the oil, sugar and salt that we use in our food are pure substances as they are made up of single kind of materials. There are certain materials which are made of more than one kind of substances. These are called mixtures. The various substances that are present in a mixture are called the components. Examples are uncleaned wheat, paddy, rice and other food grains. They contain, in addition to the food grains, the other components like pieces of straw, stones or gravel and sand. Do you know that the milk that we drink and the air that we breathe are also mixtures? Depending on the way in which these components are present in a mixture, there are two types of mixtures. Matter, pure substances, mixtures, elements, compounds, homogeneous mixture, heterogeneous mixture. Serial number, pure substances, mixture. 1. Substance in which all the molecules are of same kind. Substance in which all the molecules are not of the same kind. 2. It is either an element or a compound. Most naturally occurring substances are mixtures. 3. Each pure substance has its own characteristic properties like melting point and boiling point. Types of mixtures. Homogeneous mixture. The mixture in which all the constituents or components are evenly spread and each part of the mixture has the same properties is called homogeneous mixture. For example, salt and water. Every drop of water that you taste will be uniformly salty. Heterogeneous mixture. The mixture in which all the constituents are not evenly spread and each part of the mixture may not have the same properties is called heterogeneous mixture. For example, sand and sugar. If you take the mixture in two separate spoons, the amount of sugar in the sand will vary in both the samples and not be the same. When a mixture has one of its components as liquid, it may form a solution. In that case, we call the mixtures homogeneous solutions, if not heterogeneous solution. A solution is formed when a solid is mixed with liquid or two or more liquids are mixed together. The substance in lesser amount in the solution is called solute and the substance in larger amount is called the solvent. Differences between homogeneous solution and heterogeneous solution. Homogeneous solution, heterogeneous solution. Clear and transparent solution. Translucent or opaque solution. One of the components may settle at the bottom of the container in some cases. The composition of the solution is uniform. Composition of the solution is not uniform. Light passes through the solution without any obstruction. Light is blocked by the components of the mixtures or gets bounced in different direction when passed through the solution. Individual components can be separated only by complex methods of separation such as fractional crystallization or distillation. Individual components can be separated by physical methods. Pure substances consist of only one kind of particles, while a mixture consists of two or more types of particles. The mixtures can be separated, whereas pure substances cannot be separated. There are several natural substances such as air, sea, water and soil, etc., which are mixtures and have more than one component. For example, when creamy curd is churned with cold water thoroughly, it separates into butter and whey. The whey is used as lassi and the butter is used for the cooking purpose. Some mixtures are prepared for our composition. For example, the fruit salad is the examples of mixture which we consume often in our daily lives. However, when we have mixtures which cannot be used directly for a specific purpose, We need to separate them before using. Let us find out what other reasons are there for separating components in a mixture. Need for separation. Mixtures need to be separated because only one of the components may be useful, or both or all. The components are separately used but not as a mixture. For example, filtering of tea leaves from tea, gravel and stones from cereals, pulses, etc. Removing chalk and straw. Methods for separation. Separation means removing one component from mixture of two or more components. The choice of the method of separation depends on the properties of substances to be separated. If the quantities mixtures which need to be separated are small, we can use some common methods such as hand picking and sieving, etc. Let us find out which methods are more suitable for different types of mixtures. Hand picking. The method is employed for the mixtures which are small in quantity. Its components vary in color, size and shape, etc. Hand picking method is usually done to separate undesirable substances from a given sample of substance. For example, we can remove small pebbles, husk or unwanted grains of other cereals like wheat and rice, etc. However, the disadvantage of this method is that it is time-consuming and laborious. Threshing. The process of separating stalks from grains and pulses is called threshing. This method involves beating the stalks to separate from the grains. You must have seen bundles of paddy stalks and wheat stalks in the field after harvesting. These stalks are dried in the sun before separation of grains from them. Each stalk has large number of grains attached to it. So the farmers make small bundles of these stalks and then hit them hard against a wall of mud or any hard surface. In doing so, grains separate from the stalks. The grains thus obtained may still be covered with their seed coat and tiny pieces of stem called chaff. Real life connect. Prepare a mixture of wheat grains, dry pieces of straw and leaves. Place the mixture in a flat steel plate. Place the table fan on the edge of table. Spread a newspaper on the ground below the fan. Switch on the fan. This will provide you with the wind factor. Hold the plate in direction of wind and allow the mixture to fall down gently and evenly. What do you observe? We observe that the wheat grains fall down in a heap on the newspaper, whereas the straw and leaves are carried away by the breeze of the fan. Why does this happen? This happens because of the difference in their heaviness, that is, the wheat mixture is heavier and hence falls down vertically, forming a heap. The leaves and stalk, lighter in weight, are carried away by wind. Winnowing. Winnowing is a method where wind is used to separate the substances. When a mixture of light and heavy solid substances are dropped from a height, the wind carries the lighter substances away and the heavier substances fall down directly, thus separating the lighter and heavier components of a mixture. This method is generally used by the farmers to separate the husk from grains. A farmer allows the mixture of grains and husk to fall down from a height. Due to difference in the weight of the components, the grains, which is the heavier component, falls down vertically and forms a heap, while husk, being the lighter component, is carried away by the wind. It falls at a distance and forms a separate heap. Sieving. This method is used to separate the mixture of components which are of different sizes. When a mixture of particles is passed through a sieve, the fine particles pass through it, whereas the coarse particles remain at the top. This is how the separation occurs. You must have seen at home your mother sieving the wheat flour, atta, in the kitchen. When wheat flour is sieved, the fine particles of flour pass through the holes of the sieve, while the bigger particles, such as the husk, are left on the sieve. However, nowadays people have started consuming wheat flour along with the husk as it provides useful roughage for our body. Real life connect. Take sand which is mixed with stones and pebbles of different sizes. Pass this mixture through the sieve that is commonly available. What do you observe? We observe that the stones and pebbles remain at the top, whereas the finer sand particles pass through the sieve. Hence, separation occurs. Sedimentation and decantation. We know how to separate mixtures in which all the components are solids. How do we separate a mixture which has a liquid component? In that case, we use different methods such as sedimentation or decantation. In a sample of mixture of water with an insoluble solid component, the solid component tends to settle down after some time if left undisturbed. The process of settling down of heavier insoluble particles in a mixture with liquid water is known as sedimentation. Once the solid components of the mixture have settled down, the liquid forms a clear layer. The settled solid components are called sediment. Above the sediment, a layer of clean liquid is formed. This layer can then be poured into another container. Now you have separated the solids from the liquid. This separation of clear liquid from a mixture in which sedimentation has taken place is called decantation. Sedimentation is based on difference in the heaviness of the two components of a mixture. Solids which are insoluble in the liquid and heavier than the liquid in a mixture are separated by sedimentation followed by decantation. Filtration. Another easy method to separate insoluble solids from liquids is filtration. Filtration is defined as the process of separating the insoluble and suspended solids of various sizes from a liquid using a filter. The liquid obtained in this process is called filtrate. The best example of filtration is filtering tea. After preparing tea, it is passed through a strainer or wire mesh or a piece of cloth to separate the tea leaves. Tea leaves are bigger in size than the holes of the mesh or pores of the cloth. Therefore, they are retained in the strainer which works as filter. The tea in this case is the filtrate. A commonly used filter in laboratories is filter paper. Filter paper has tiny holes which traps the solid components of the mixture but allows the liquid to pass through it. Wonder why? Have you wondered how we can separate mixtures in which both components are liquids and are of different masses or weight? Let us find out. To separate two liquids which do not mix with each other, we use an apparatus called separating funnel. Separating funnel is a cone-shaped funnel made of glass and it has a stopper and an outlet at the lower end. Let us use a separating funnel to separate a mixture of two liquids in which one is heavier than the other. Take a separating funnel and to it add castor oil and water which are immiscible. Shake the mixture well. Place an empty beaker under the funnel. Close the stopper of the funnel. Allow it to rest for 5 to 10 minutes. Observations and conclusion. We observe that castor oil, which is lighter, will form a layer at the top while water will form a layer below it. Castor oil can thus be separated from water. Open the stopper. Allow the water to trickle down into the empty beaker kept under the separating funnel. When all the water has been collected in the beaker, close the stopper. The castor oil is left inside the funnel. Thus, you have separated two liquids which are immiscible. Loading. You must have seen while doing the process of sedimentation that it takes a long time for the sediments to settle. Suppose you have a large quantity of mixture. In that case, the time taken for sedimentation will be even longer. The mixture can also contain extremely small insoluble particles. Such particles tend to remain suspended in the liquid and take a long time to settle. Also, they are so tiny that they can even pass through the holes of a filter paper. In such cases, we can hasten the process of sedimentation by adding a chemical to it. The chemical helps in increasing the speed or the rate of sedimentation. This process is called loading. The suspended particles from a mixture can be separated quickly by this process. Suppose you have a sample of impure water which has fine soil particles as impurities. If you put a piece of alum or a chemical to such water sample, it is called loading. The alum particles attach themselves to the particles suspended in the water. This makes the soil particles heavy and they quickly settle at the bottom. Centrifugation. Sometimes a mixture of extremely small size solid particles and liquid cannot be separated by using a sieve or a filter paper. They can be separated by a process called centrifugation. The apparatus used for this process is called centrifuge. When the centrifuge rotates rapidly with the mixture inside it, the denser components move inwards. This helps the solid particles settle down quickly and completely. For example, removing of fat from cream or creamy milk by using the process of centrifugation. Separation of soluble substance from liquid material or solution. We know how to separate insoluble solids from liquids, but how can we separate soluble solids from liquids? Let us find out. Evaporation. Sometimes we may need to separate the soluble solid from a solution, which is a mixture of solid and liquid. In that case, we can allow the liquid to evaporate completely and the solid is left behind. Thus, evaporation of liquid helps us in obtaining the soluble solid from the mixture. The process in which a liquid is transformed into gaseous state without boiling is known as called evaporation. Evaporation occurs at the surface of the liquid. For example, have you wondered what happens to water that has spilled on the floor? Will you find it on the floor after few hours? No, you will not find it because it has evaporated and escaped into the atmosphere. Salt is obtained by the process of evaporation. To obtain common salt from seawater is collected in open shallow pits during high tides. Slowly on the water evaporates due to the heat of the sun. When the water evaporates completely, solid salt is left behind. This salt is then sold directly or taken to the factory, cleaned and processed, and finally packed to be sold in the market. Condensation. Evaporation helps in separating out the solid substances, but if we cool the evaporated vapors of the liquid, we can obtain the liquid also. The vapors of the liquid are condensed or cooled and turned back into liquid. Condensation is the opposite of evaporation. If you wish to obtain water too from the solution of salt and water, we have to use evaporation and condensation method together. Evaporation helps in separating solids from the solution and condensation gives you back the liquid. In the process of condensation, the vapors are cooled down considerably so that they change back into liquid. Real life connect. Mix 1 or 2 spoons of common salt in glass of water and make a clear solution by stirring it. Sip it a little. It tastes salty. Pour this solution in an aluminum kettle and close its mouth with the lid. Heat the kettle on a gas burner and wait till the steam comes out freely from its spout. Place a few ice cubes in the frying pan and hold it in slanting position in front of the spout of the kettle. Collect the condensed water thus obtained. What do you observe? We observe that the steam which comes out from the spout comes in contact with the cold surface of frying pan and condenses to form droplets of water on the underside of frying pan. These droplets of water trickle down the side of frying pan and start falling down. Conclusions. Taste the water so collected, it is no longer salty. The salt is left behind in the kettle. Thus, we can separate salt and water from a salt solution using the process of evaporation and condensation. Distillation. Suppose you wish to obtain only the liquid component from a mixture of soluble solid and liquid. In that case, the method of distillation is used. Distillation method is often used to purify liquids by boiling and condensing the vapors formed. We can obtain pure water from seawater by using this method. Let us see how. Take 2 boiling tubes and name them A and B. In tube A, take a sample of seawater. You may use salt solution instead. Close the mouth of test tube A with a bent tube. Let the other end of bent tube dip into test tube B as shown in the picture. Keep tube B half immersed in a beaker of cold water. Now heat tube A. The water will start boiling after a few minutes. The steam thus produced will pass into tube B through the bent tube. Here the steam will condense as the inner surface of the test tube is cold. The liquid that condenses in the test tube B is known as the distillate. The beaker of cold water helps the test tube remain cold throughout the process. A special apparatus called Liebig's condenser increases the efficiency of the process of distillation. Observe the picture given below. The condenser surrounds the delivery tube and it has a constant flow of cold water. The vapors thus condense in the delivery tube itself and the distillate is thus collected directly in a test tube. The round-bottomed flask also holds more water than a test tube. Thus, this apparatus is much more useful and efficient than the one which is shown previously. Magnetic separation. We know that some materials such as iron and nickel get attracted to a magnet as they are magnetic in nature. This magnetic property can be used very well to separate a mixture of magnetic and non-magnetic material by using a magnet. For example, if you have a mixture of iron fillings and sand, you can move a bar magnet through the mixture. The iron fillings will get attracted to it and stick to it. The magnet picks out only iron fillings from the sand. Thus, the components of the mixture, that is sand and iron fillings, are separated. Separation using more than one method. Sometimes a mixture may be more complex. It may have more than two components. If a mixture contains more than two components, then it requires a combination of several methods of separation. For example, the mixture containing sand, water and salt needs filtration or decantation and evaporation process too for separating sand, salt and water. Another example we can see is mixture of oil, water and fine sand particles. We have to use the process of decantation as well as loading. Oil gets separated by decantation, whereas the fine soil particles separate by loading. Water, a universal solvent. You must have observed that most of the solutions that you studied had water as solvent. Water is called as universal solvent because it can dissolve most of the substances in it. Also, it is essential for all living beings. 70% of our body is made of water. Some of the most essential functions of water are: water is essential for all the metabolic processes in all living things. It dissolves more substances than any other liquid. Summary of methods used to separate a mixture. Process. Type of mixture for which this method is used. Examples: sedimentation and decantation, used for separating solids and liquids, separating mud and sand, impurities from water. Centrifugation, used for separating very fine and tiny solids from liquid, separating butter from cream. Filtration, used for separating an insoluble solid from a liquid, separating sand from water. Evaporation, used to obtain the solute from a solution, for obtaining salt from salt solution. Simple distillation, used to obtain the solvent from a solution, for obtaining pure water from seawater. Subject integration. In daily life, with the help of separation, we get definite size, weight, and most important, we get active constituent from substance. We can remove unwanted particle from substance with the help of separation. In the medical field, in pharmaceutical companies, separation is the most important process. The separation stage is applied to remove unwanted byproducts. The most used technologies are chromatography, nanofiltration, ultrafiltration, sublimation, desublimation, distillation, and crystallization. Skills and values. Mixtures and solutions have common occurrence in our everyday lives. The separation of mixtures is a fundamental concept that involves separation of different components based on their physical or chemical properties. Rapid review. The matter which is made up of a single substance is called as pure substance. Matter which is made up of two or more substances is called mixture. Hand-picking method is employed for mixtures of small quantities when they vary in color, size and shape, etc. The process of separating stalks from grains and pulses is called threshing. This method involves beating the stalks to separate the grains. Winnowing is a method where wind is used to separate the substances. When a mixture of light and heavy solid substances is dropped from a height, wind carries the lighter substances away, thus separating the lighter and heavier materials in a mixture. Usually, lighter chaff is separated from heavier grains or pulses by winnowing. Sedimentation is defined as the process of settling down of heavier insoluble particles in a mixture of water and heavier insoluble impurities. Decantation is defined as the process of transferring the clear liquid after sedimentation without disturbing the sediment insoluble heavy particles like mud and water. The process of increasing the rate of sedimentation in a suspension by adding a alum chemical is called as loading. Condensation is defined as the process of changing water vapor or any other vapor into the liquid state on cooling. Key points. Pure substances. It consists of only one kind of particles. Mixture. Mixture consists of two or more kinds of particles. Separation. Removing each component from a mixture of two or more components. Threshing. Process of separating stalks from grains and pulses. Hand picking. Picking out impurities from a sample by hand based on difference in color, size and shape, useful for mixtures. Winnowing. Using wind in separating substances based on difference in heaviness of components, usually used for separating chaff from grain and pulses. Sieving. Method to separate the mixture of components which are of different sizes. Evaporation. Process of converting a liquid into its vapor by heating it below the boiling point of the liquid is called evaporation. Distillation. A process of purifying by boiling a solution and condensing the vapors to get a pure liquid. Filtration. The process used to separate a solid from a liquid. Filtrate. The clear liquid obtained by filtration. Residue. The solid left behind after filtration. For instance, the solid left in the filter paper. Solvent. The liquid that is used to make a solution. Solute. A substance that has been dissolved in a solution. Soluble. Can dissolve in a solvent. Insoluble. Cannot dissolve in a solvent. Solution. Obtained by dissolving solute in solvent. Fill in the blanks.